Hello guys, and welcome back to JAMB chemistry class. And of course, doing chemistry today. And in the previous class, we started an introduction into chemical bonding or chemical combination. Right. So today in this class, we're going to be looking at the first type of intramolecular bond. Right. Ionic bonding, or what's electrovalent. Ionic or electrovalent what bond. So this is what we're going to look at today in this class. We're going to understand how what electrovalent what bonds exist between what atoms, right? And today we're going to see the characteristics also of electrovalent what compounds. All right. So in the previous class we gave an assignment. Please go back to that class, watch it, and what answer the questions on what on that topic, right? Because the whole topic, this is the second part of that first topic, right? We are going to continue in this sequence until we are done. We are trying to break it down evenly so that you can easily understand. We do not want to load up one full topic in one video, thereby making it too bulky for you and maybe boring for you to understand. That's why I'm making it exciting for you by breaking it down into what small chips for you to be able to easily eat up. All right. Now, do not forget that this video tutorial is brought to you, of course, by the O3Schools JAMB app. It is being currently displayed below this video. It is the best CBT practice app you can ever want to have in your phone, right? So it has all the past questions you need for all the subjects. It has wonderful features that will enable you to practice easily. Even the questions we gave you on assignment in the last video, right? You can search for them on the app and it comes easy peasy, right? So also there's a wonderful feature called the UTME challenge. It's a challenge that is being participated by students who are writing JAMB for the particular year you are writing. So you are competing with other students writing JAMB. You are winning prizes. You are also improving yourself, right? Because every Saturday we hold this competition, and then as you participate, once you participate, you see your score, right? Just like you see in your JAMB. So once you see your score, you know what your weak areas, you know your strengths, and you know where to work on. All right. So please do not joke with the app. Activation is just 2,500 naira. Make sure you activate. All right. Now we're going to look at ionic or electrovalent bond today. All right. So now in this type of bonding, that is in electrovalent bonding or the ionic bonding, there's usually transfer of electrons. These electrons are the valence electrons. That is the valence electrons. There's usually a transfer of electron from one atom to the other, leading to the formation of ion. Leading to the formation of ions. All right. So we say in electrovalent bonding, right, there is transfer of electrons, that is transfer of valence electrons from one atom to the other, leading to the formation of ion. So in this case, we have what we call the electron donor, and then we have the electron acceptor. So one atom donates the electrons, while the other atom accepts the electron. All right. So but the transfer of electrons between the atoms, leading to the formation of of ions. Right. So electron donor, electron acceptor. Let's see how it comes to play here. Right. So the electron donor, right, is usually a metal. It's usually a metal. And once it donates this electron, it becomes a cation. A cation is a positively charged ion, right? So now the electron donor will donate the electron, and it's usually a metal. And once it does this, it becomes a cation, a positively charged ion, right? A positively charged ion. All right. Now, while the electron acceptor is usually a non-metal, right? This is electron donor. Now, that is this. Now, electron acceptor The electron acceptor is usually what? A non-metal. It's usually a non-metal, and once it what accepts what this electron, it becomes what? An anion. An anion. An anion is what? It's a negatively charged ion. All right. So let's get back to what we are saying again. Let's go back again from the beginning. We say what? Electrovalent in electrovalent bonding, right? There's transfer of electrons from one atom to the other, right? That is transfer of valence electrons, leading to the formation of what? Of ions, right? That's the first thing we said. Then we'll move over to say to the concept of electron donor and electron acceptor in electrovalent bonding. And we'll say that what? The electron donor is usually a metal, and it becomes what? A cation afterwards, right? So once it donates what? The electron, right? It becomes what? A cation, a positively charged ion. Why what? The acceptor, the what? The acceptor, when the metal what donates it, the non-metal accepts it, right? So once it accepts it, it becomes what? An anion, which is a negatively charged ion. And that is why we usually say that what? That metals ionize by electron loss. So now a metal what? Ionize becomes an ion when it what? When it loses electrons. When it what? It gives electron to another atom. It becomes what? An ion when it what? When it loses an electron. That's why we say metals ionize by electron loss. You must know this. Metals ionize by losing electrons. While of course non-metals ionize by gaining electrons. By gaining electrons, right? So metals ionize by electron loss, while non-metals ionize by gaining what? Electrons, right? Now note that what? The cations and the anions that are what? That are formed, right? During this transfer of electrons, they are usually what? Very stable. They are usually very stable. Let me clean this up and let's get that to the board, right? We say that the cations and the anions that are what produced during this process, right? During this transfer of what? Of electrons are very what? Stable. The cations and the anions produced during this process are what? Are very stable. And what does stable mean? It means that what they have what? That they behave like the noble gases, right? That they have attained the what? The electronic configuration of noble gases. That is what? They have the electronic configuration of noble gases. And what is that? That is they have what? That is they have um completely filled completely filled outermost electrons. Completely filled what? Outermost electrons. Outermost shell rather. All right. So the outermost shell is what is completely what? Filled. Right. Now the cations and anions that are formed during this transfer of what? Of electrons are what? Very stable, which means that what? They have the electronic configuration of the noble gases, and what? They have completely filled outermost what? Shell. Right. I will there now. Now, having known this, because because in electrovalent what? Bonding, right? There's usually what? The transfer of electrons that leads to the formation of ion. That is why we now call this electrovalent bonding the same thing as what? As ionic what? Bonding. So this is why we say they are what? Called what? Ionic bonds, because what? They lead to the formation of what? Of ions. Once these electrons are transferred, they lead to what? Formation of what? Of ions. Let's see examples of electrovalent compounds. Examples of electrovalent compounds will be between what? A metal and a non-metal. Example will be, of course, one between sodium and chlorine, right? This is a metal, this is a non-metal. Another example will be between, let's say, magnesium and oxygen. This is a metal, this is a non-metal. Yeah, right? This is M, this is NM. This is N, this is NM. Or also, we can have what another one between calcium and fluorine. We can also have another one between four now between what silver and bromine. All right. So this is what this is what a metal rather metal, and this is what a non-metal. This is a metal and this is a non-metal. These are examples of what of electrovalent what compounds. Right, electrovalent compounds are formed between what this what are metals and what are non-metals. These are examples. You should just keep them in your mind and know them. All right. So we're going to take this first example to drive the point home about how what this electrovalent what bonding what is formed between what a metal and a non-metal. But please note that before the transfer of these electrons, right? Before the transfer of these electrons, they are not stable. Right, the compounds was involved in this what electrovalent bonding are not stable before the transfer of electrons, but they become what stable. That is, they have the electronic configuration of the noble gases after what the transfer of electrons. After the transfer of electrons, they become stable, but before the transfer, they are unstable. They are not stable. That is why, of course, they are going into what bonding. All right, now let's see what happens. Let's see what happens in sodium and chlorine, for example. Sodium is the 11th element, right? So sodium is 11th element. All right, so we have a sodium. This is Na. This is 23, mass number 23. Of course, atomic number 11. All right, so we also have what this is before combination. Let's say before combination. Before what they combined. This is sodium 23, atomic number 11. Now what happens? This is can be broken down into 2, 8, what 1, isn't it? That means it has 2 electrons in the K shell. In the L shell, it has what 8. There in the what KLM, in the M shell it has what 1. All right, so we can use what the electron dot and cross method in this what channel. In the previous episode of JAMB chemistry, we have taught electronic configuration, right? We have taught the electron dot and cross method, the box diagram method, the SPDF method. We have taught the principle for writing electronic configuration. Everything is on this channel. If you have not watched it, you have no business here. Please go back, watch it, understand the episode, and then come forward to this class. It's very, very important. It is very, 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 very important. Please do not joke with your JAMB app. Download your O3Schools JAMB app right away and start practicing. Let's join me. So now you see, this is 2, this is 8, this is 1. Right? So now let's represent it using the electron dot and cross diagram. So in the first K shell, there will be 2 electrons in the outermost shell, right? Then of course, in the next shell, we're going to have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now, there's still one more electron. 2 plus 8 is 10. The last electrons will be what in the last shell. So this is, let's say, let me put it here. All right, let me put it here. Okay, so this is 2, 8, 1. This is before combination, before they combine. Let's see chlorine. This is chlorine. This is 35, and this is 17. So that will be what 2. Okay, the first shell will be what will carry 2 electrons, right? Then the next shell we have 8 electrons. 2, 2, 2. That is 2 plus 8, 10. Right? Remaining how many electrons? Remaining 8. So I have what 1, 2, 3. All right. Now let's see this together. Now this is what 2, 8, 1. That is 2, 8, 7 here. Yeah, 2, 8, 1. All right. So this is what sodium atom 2, 8, 1. Chlorine atom atomic number 17, 287. It has 7 electrons in its what in its atomos shell in chlorine here. While here in sodium it has 1 electron in its atomos shell. So you can see very well that Sodium wants to attain the stable octet structure. It wants to attain what? It wants to be stable. It wants to attain stability, right? But it has what? One electron in its what? Atomic shell. Now, but chlorine now has what? 7 electrons in its atomic shell. Sodium needs 7 electrons to make it what? 288. But chlorine needs just one to make it what? 288. You get? So they can help each other, right? Now, he said that you are saying sodium chlorine will give 7 to sodium, and sodium will now give 1 to chlorine. I want you to reason wide, to reason very, very what? Broadly. Now, is it easier for sodium to give 1 to chlorine, right? Is it easier for you to give 1 to chlorine and not receive anything, or for chlorine to give 7 to sodium and chlorine not receive anything? So to make this very, very easy, you can see that this electron in this atomic shell, this can be transferred to this one. Sodium can transfer this one to chlorine to make here stable, and here will also be what? Be stable. So sodium will have 28, while chlorine will have 288, and they will both be what? Be stable. It's very easy, it's easier rather for sodium to give the 1 to chlorine, right, than for chlorine to be giving 7 to sodium, 7 electrons to sodium. So now, this is what happens here. This electron here is transferred to this what? To this what? To this chlorine atom. So this is before combination, but after combination, I'm going to have what now? That this 1 electron has been transferred to chlorine. All right, so I'm going to have chlorine atom and sodium atom 0, 1, 1 in the first shell, and then in the next shell is going to be having what? 8 electrons in the what? In the atomic shell. This is now sodium ion. Sodium ion, right? Having what? 10 electrons, right? It has sacrificed 1 electron to what? To chlorine. It has transferred its electron to chlorine. So this will now become what? Sodium what? Ion, right? Now that is what? 2, 8. It is stable. Why chlorine now? We now have 2 electrons in the first shell. In the next shell, to have 8 electrons. And then in the third shell, to have what? 8 electrons. All right. So you see here now, this is now chlorine ion, right? It will become what? Chlorine what? Ion. This will become sodium ion. This will become chlorine ion. This one is the what? This sodium is the what? This is the electron donor. Why this chlorine is what? Is the electron acceptor. The chlorine atom accepts what? The electron, while the sodium atom what? Donates or transfers the electron to it. So now, and we have said before that once a metal or transfers electrons, it becomes what? It becomes positively charged. It turns to a cation. It becomes a cation. That's why you are seeing plus on top of the sodium, while you are seeing minus on top of what? Of the chlorine. So this is the electron acceptor. Once it accepts the electrons, it becomes what? Negatively what? Charged. That is what? Chlorine what? Ion. All right. So this is what happens here. So this is 2, 8. Why this one what? 2, 8, 8. They are both what? Stable. If you see now, they are both what? Stable. All right. So this has attained the stable octet structure, and this has attained the stable octet structure. And of course, the purpose of what? Of the bonding has been achieved. So also is seen in other what? Electrovalent what? Compounds. This is what happens. The transfer of what? Electrons between a metal to a what? To a non-metal. All right. So now, having seen this now, we are going to now look at what some of the characteristics of what? Of electrovalent what? Compounds. Right. We have seen here what happens. Sodium transfer electron to chlorine to become what? To become stable, right? Chlorine accepts it and becomes what? An anion. An anion. While sodium transfers its electron to become a cation. That is done. Now let's see characteristics of electrovalent compounds, right? Let's see characteristics of electrovalent compounds. How do we know? How do we test that? How do we know that this compound is electrovalent, right? Now, these kind of questions are questions that come out in the exam, so you have to be very, very, very smart about it, right? So, what is the first thing you need to know? The first thing you need to know is that what that electrovalent bond, it's what happens between what a metal and a non-metal. So electrovalent what bonds what occurs what between what a metal and what and a non-metal. Examples of electrovalent compounds will be what? Sodium chloride, of course. We are going to have magnesium oxide, right? Between calcium fluoride, right? We're going to have silver bromide. These ones are examples of what? Of electrovalent what compounds, right? They occur between a metal and a non-metal. Electrovalent bonds what exist between what a metal and a non-metal. These are examples. Then another thing you need to know is that what that electrovalent compounds have a high melting and boiling point. They have high melting and boiling point. Right. They have high melting and boiling point. Why? It's due to the what? To the great what bond between what those atoms. Right. Very, very great electrovalent bond due to the very, very great, very, very massive what electrovalent bond. Electrovalent bond is very, very, very what? Very, very massive. So it's very, very great. So that is why they have high melting and boiling point. For example, sodium chloride, for example, has a boiling point of 1465 degrees Celsius. NaCl has a boiling point of 1465 degrees Celsius. That's NaCl. Magnesium oxide itself has a boiling point of 3600 degrees Celsius. Approximately 3600 degrees Celsius. Calcium fluoride itself, CaF2, has a boiling point of 2533 degrees Celsius. While what is now left there? Okay, silver bromide, AgBr, has a boiling point of 1502 degrees Celsius. All right, so these are not a small boiling points. These are very, very high boiling points, and this happens because of the great electrovalence was bond between what the atoms that are formed. All right, so let's see another characteristics of what of electrovalent bond. Electrovalent what compounds rather are they are solids at room temperature. They're usually what solids at what at room temperature. You have to take note of that very well. Then of course as they dissociate in water to form ions. They dissociate in water to form what ions. This is another what characteristics of what of electrovalent what compounds. They dissociate in water to form what ion. And of course, number 5, as they dissociate in water to form ions, right? This means that what they conduct, they are good conductors of electricity, right? They conduct what electricity, they conduct electricity and can be used as electrolytes. So because they are what? Because they dissociate in water to form ions, they conduct what electricity and can be used as electrolytes. They can be used as electrolytes. Very, very, very necessary to know that. Also, number 6, I think this is the last characteristics we'll look at, right? They do not dissolve in non-polar solvents. Non-polar solvents. Non-polar solvents like alkanes, ether, like kerosene, right? They do not dissolve in non-polar solvent like benzene too, even pyridine, right? They do not dissolve in non-polar solvent like this, but they dissolve in polar solvents, e.g., we have like ethanol, like water, and ammonia. All right, so we're going to quickly run through the characteristics again. We say what electrovalent bond what occurs between what a metal and a non-metal. This one good characteristic. We saw examples. Then we say they have high melting and boiling point because of the great what electrovalent bond, right? They will say they are solids at room temperature, right? And we say they dissociate in water to form ions. We say as they dissolve in water to form ions, right? They conduct electricity and can be used as electrolytes. Then we say number 6, they do not dissolve in non-polar solvents like alkanes, like ether, like kerosene, like benzene, but dissolve in polar solvents like water, ethanol, and ammonia. So this is where we're going to stop for electrovalent what compound, or electrovalent bond rather, right? So in the next class, we'll see another type of what intramolecular bond until we are done with all the bonds before we move on to another what topic. So please follow us sequentially as we progress. And if you have not watched the video on electronic configuration, please search for it on this channel on the previous episode and make sure that what you watch it. Please do not forget to like this video. Do not forget to like this video. Just click on the like button right away. Then do not forget to subscribe. Click on the red subscribe button below this video. Subscription is free, right? It's just so that whenever we publish a new video, you'll be among the first to be notified via your phone that we have published a new video. And do not forget to share. Do not be stingy. Share this knowledge to what? To your class group, to your friends, and so on and so forth. Share the video so that others can also what, learn and join in this class. Thank you for watching, and I will see you in the next class.